Hello there and welcome. Tonight we're going to explore a hidden world that lives all around us, a world we walk past every day without noticing. Tonight we journey into the kingdom of mushrooms. If you are here to relax or maybe drift off to sleep, you are in exactly the right place. Let your shoulders drop. Take a slow breath. Let your mind wander freely as we explore together. Mushrooms are strange and beautiful. They are not plants even though they grow from the ground. They are not animals even though they are closer to us than to any tree or flower. They live in their own secret kingdom. They have been on this planet longer than the forests have existed. Some mushrooms glow in the darkness like tiny lamps scattered across the forest floor. Others stretch for miles underground where we cannot see them. They connect trees to each other through invisible threads. They whisper messages through the soil. Some mushrooms are brighter than any paint you've ever seen. Reds and blues and purples that look impossible. Others are so deadly that one small bite could end a human life. But mushrooms also heal us. They clean our polluted world. They help make our bread rise and turn grapes into wine. They break down everything that dies and turn it back into soil so new life can grow. Scientists believe mushrooms might help us survive on other planets one day. They can eat radiation. They can live in space. They survived when dinosaurs walked the earth, and they will probably survive long after we are gone. If you are enjoying this journey and want to see more videos like this, feel free to like and subscribe. It helps other people who love science and sleep find their way here too, but there is no pressure. Just relax. Let the story carry you wherever it wants to go. Tonight we will discover 100 quiet truths about mushrooms. We will learn how they talk to trees, how they can control the minds of insects, how they might hold cures for diseases we have not solved yet. We will see how they light up the night and how they remember the past. This is not just about learning facts. This is about drifting through wonder. So get comfortable. Close your eyes if you want. Let the world of mushrooms unfold around you like a gentle dream. We begin now. First, 25 facts. Fact 1. Mushrooms are more closely related to animals than to plants. This surprises almost everyone who hears it for the first time. When you see a mushroom growing quietly from the soil, it looks like it belongs with flowers and trees. But scientists discovered something amazing when they studied the genes inside mushrooms. Mushrooms share a common ancestor with animals, not with plants. This means that in the deep history of life on Earth, mushrooms and humans split from the same family tree. Plants went a different direction entirely. Mushrooms breathe oxygen just like we do. They breathe it in and release carbon dioxide just like your lungs do right now. Plants do the opposite. They take in carbon dioxide and release oxygen. The walls of mushroom cells are made from something called chitin. Chitin is the same material that makes the hard shells of insects and crabs. Plant cell walls are made from cellulose, which is completely different. When you walk through a forest, it might seem like mushrooms belong with the moss and ferns. But the truth is they have more in common with the animals walking through that forest. This hidden connection changes everything. It means mushrooms are distant cousins to us. They are part of our family in ways we never imagined. Fact 2. Some mushrooms can glow in the dark with their own natural light. Imagine walking at night through a forest, where the ground is covered in soft green lights. Tiny mushrooms glowing like candles scattered in the leaves. This is not a dream or a fairy tale. It is real. More than 70 types of mushrooms can create their own light. Scientists call this bioluminescence. It is the same kind of light that fireflies make when they blink in summer evenings. The mushrooms that glow include ones with names like foxfire fungi and honey mushrooms. They shine with a greenish or bluish colour that looks magical in the darkness. Why do they glow? Scientists think the light might attract insects at night. When insects come close, they brush against the mushroom and carry away tiny spores that will grow into new mushrooms somewhere else. Or maybe the glow protects the mushroom from being eaten. Some animals might think glowing things are poisonous or dangerous. The light comes from a chemical reaction inside the mushroom. Special molecules react with oxygen and create light without heat. It is cold light, pure and gentle. To see one of these glowing mushrooms in the wild feels like witnessing ancient magic. Here is life creating beauty from decay. Here is proof that even in the darkest places, nature finds ways to shine. Fact 3. A single fungal network can stretch for miles underground. When you look at a mushroom, you're only seeing a tiny part of the whole organism. The mushroom itself is like the fruit on an apple tree. Underground there is something much bigger. It is called mycelium. Mycelium is made of thin white threads that spread through the soil like a spider web. These threads are thinner than a human hair but incredibly strong. They weave around rocks and roots and the remains of dead leaves. In some forests, one single mycelium can stretch for miles in every direction. It can connect thousands of trees together. It can cover entire hills and valleys. Imagine a living net made of thread spreading beneath your feet, invisible but always working. This network does many jobs. It recycles dead things and turns them back into food for plants. It carries water from wet places to dry places. It even helps trees send sugar and nutrients to each other. When you walk across a meadow, you might be stepping on one enormous creature that is older than any tree you can see. This hidden world beneath us is always busy, always growing, always connecting life to life in ways we are only beginning to understand. Fact 4. The largest living organism on Earth is a mushroom. In the mountains of Oregon in the United States, there is a forest that looks ordinary. Pine trees stand tall. Streams flow through valleys. Birds sing in the branches. But hidden under the soil is something extraordinary. Scientists discovered that almost the entire forest is connected by one single fungus. This fungus is called Armillaria ostoya, and some people call it the honey fungus. The mycelium of this one fungus spreads across nearly 4 square miles. That is bigger than many towns. It weighs more than several blue whales combined. Scientists think this fungus is thousands of years old. Every honey mushroom that pops up from the ground in that forest is just one tiny piece of this giant creature. When researchers realized what they had found, they were amazed. They had been walking through a forest thinking they saw many separate living things, but actually they were walking on top of one vast being that had been growing silently for longer than human history. This fungus is older than most civilizations. It has survived ice ages and droughts and fires. It is quiet and patient, and it just keeps growing, inch by inch, year after year, beneath the feet of hikers who have no idea it is there. Fact 5. Mushrooms can send electrical signals to communicate. Even though mushrooms have no brain and no nervous system, they can send information through their threads. Scientists have measured tiny electrical pulses travelling through mycelium. These pulses look a bit like the signals that move through the nerves in your body. The patterns change depending on what is happening around the mushroom. If there is danger nearby, the signals speed up. If there are nutrients available, different patterns appear. Some researchers think these pulses might even be a kind of language. The mushroom could be telling other parts of itself what is happening and what to do next. Imagine an underground internet woven into the forest floor, messages travelling through fungal threads, carrying news about food and water and danger. Trees might use this network to talk to each other too. A tree that has plenty of sunlight might send sugar through the fungal threads to a younger tree growing in the shade. This is not thinking the way humans think, but it is communication. It is information flowing through a living system. It reminds us that intelligence comes in many forms. The earth is full of conversations we cannot hear, signals moving through the soil in languages we are only starting to decode. Fact 6. Some mushroom spores can survive in space. When scientists wanted to test what kinds of life could survive beyond Earth, they brought mushrooms along for the journey. They sent fungal spores outside spacecraft where there is no air, no protection, and deadly radiation from the sun. The temperature swings from boiling hot to freezing cold. Most living things would die instantly, but many of the mushroom spores survived. They floated in the vacuum of space for weeks. When scientists brought them back to Earth, the spores were still alive. They could still grow into new mushrooms. This incredible toughness makes scientists wonder if life could travel between planets. Maybe mushroom spores could hitch a ride on a meteorite and survive the journey through space. Maybe life on Earth originally came from somewhere else, carried here by tiny travellers like fungal spores. This idea is called panspermia. Whether or not it is true, mushrooms have proven they are survivors. They can endure conditions that would destroy almost any other form of life. The humble mushroom sitting quietly in a forest might carry within it the ability to cross the stars. Fact 7. Mushrooms have been found growing inside nuclear reactors. After the Chernobyl disaster in 1986, the nuclear reactor became one of the most dangerous places on Earth. Radiation levels were so high that humans could not go inside without dying. But when scientists finally sent robots in to explore, they found something shocking. Mushrooms were growing on the walls, not just surviving, but thriving. Certain types of fungi seem to actually grow toward radiation. They contain a substance called melanin, the same pigment that colors human skin. In these mushrooms, melanin appears to change radiation into energy that the mushroom can use, almost like plants turn sunlight into food. Imagine a mushroom eating radiation the way you eat breakfast. What kills us feeds them. This discovery has enormous possibilities. Maybe one day we could use mushrooms to clean up nuclear waste. Maybe they could protect astronauts traveling through space, where cosmic radiation is dangerous. In the most toxic, deadly places humans have created, mushrooms found a way not just to survive, but to flourish. They turn poison into fuel. They grow in ruins. They remind us that life is more creative and resilient than we ever imagined. Fact 8. Fungi can break down plastic and oil. One of the biggest problems humans face today is pollution. We have created mountains of plastic that will last for hundreds of years. We have spilled oil into oceans and soil. These materials do not break down naturally. But scientists have discovered that some mushrooms can digest them. In the Amazon rainforest, researchers found a fungus that can eat polyurethane, one of the most common plastics in the world. Other fungi can break down oil spills, turning toxic sludge into harmless material. Imagine a landfill full of plastic bottles and bags slowly disappearing as mushrooms eat their way through it. Imagine an oil spill cleaned not by machines, but by fungal threads spreading through the contaminated soil. Scientists are now trying to figure out how to use these mushrooms on a large scale. They dream of fungal factories that could solve our waste problems. In a world drowning in garbage, mushrooms offer hope. They show us that nature often has solutions to the messes we create. All we have to do is pay attention and learn from the quiet workers already doing the job. Fact 9. There are mushrooms that can kill you with a single bite. Not all mushrooms are safe. Some carry poisons so powerful that even a small taste can be deadly. The deathcap mushroom is one of the most dangerous. It looks plain and ordinary, with a pale greenish cap and white stem. Someone might easily mistake it for a safe mushroom, but inside it contains toxins that attack your liver and kidneys. The worst part is that you might not feel sick for many hours after eating it. By the time symptoms appear, the damage is already done. Throughout history, poisonous mushrooms have killed kings and emperors and ordinary people who made a simple mistake. The line between a delicious meal and a fatal one can be impossible to see. Some poisonous mushrooms look almost exactly like edible ones. This is why experienced mushroom hunters spend years learning to identify every detail. They know that a single mistake could be their last. The danger in mushrooms reminds us that beauty and poison often live side by side in nature. A fragile, innocent-looking mushroom growing quietly under a tree might hold enough chemistry to end a human life. Fact 10. Other mushrooms taste almost exactly like lobster or chicken. While some mushrooms are deadly, others are delicious in surprising ways. Certain mushrooms have flavors that mimic meat or seafood so closely you might not believe they came from a plant. The lobster mushroom has a reddish-orange color and tastes sweet and rich like shellfish. Chicken of the woods grows in layers on tree trunks and tears apart in chunks that look and taste like chicken breast. For hundreds of years, people who could not afford meat or lived far from the ocean have used these mushrooms instead. They are gifts from the forest, tasting like feasts but growing free on trees and logs. To bite into one is strange and wonderful. Here is something that grew from wood, that has no eyes or mouth or blood, yet somehow tastes like a creature from the sea. It is as if mushrooms are shapeshifters of flavour, borrowing taste from the animal world while remaining something entirely their own. They blur the boundaries between plant and animal, forest and ocean, wild and familiar. Fact 11. Ancient cultures used mushrooms in sacred rituals. For thousands of years, humans have seen something special in mushrooms. They appear overnight as if by magic. They seem to come from nowhere. Ancient peoples believed mushrooms were messages from the spirit world. In Siberia, shamans used the red and white mushroom called Amanita muscaria in ceremonies to enter trance states and speak with spirits. In Central America, the Aztecs called certain mushrooms the flesh of the divine and used them in religious rituals to connect with the sacred. Even in Europe, old cave paintings show human figures holding what look like mushrooms. Some of these paintings are over 6,000 years old. To our ancestors, mushrooms were not just food. They were doorways to other realms. They were teachers and guides. They appeared mysteriously from the earth and changed the mind and opened visions. People saw them as bridges between the everyday world and the world of dreams and spirits. Today, we understand more about the chemistry that creates these experiences, but the sense of wonder remains. Mushrooms have been shaping human culture and spirituality since the beginning of art and ceremony. Fact 12. Some mushrooms take over the minds of insects. One of the strangest and most disturbing things in nature is caused by a fungus called cordyceps. This mushroom does not just grow in soil, it infects insects. A tiny spore lands on an ant. The fungus begins to grow inside the ant's body. Slowly, the fungus takes control of the ant's brain. It forces the ant to climb up a plant stem to a certain height. Then the ant bites down on a leaf and stays there, frozen. After that, the fungus bursts out of the ant's body and grows a stalk that releases more spores to infect other ants below. Scientists call this the zombie fungus because it turns living creatures into puppets. The ant is not alive anymore in any meaningful way. It is just a vehicle for the fungus to spread. This sounds like a horror movie, but it happens every day in forests around the world. It is eerie and fascinating at the same time. It shows how fungi have evolved strategies that seem almost intelligent. They manipulate behavior. They control other creatures. They use life to make more life in ways that are both brilliant and chilling. Fact 13. A fungus once wiped out entire populations of amphibians. In the late 1900s, scientists noticed something terrible happening. Frogs and salamanders were disappearing all over the world. Entire species were going extinct in just a few years. Researchers discovered the cause was a fungus called chytrid fungus. This fungus infects the skin of amphibians. Because frogs and salamanders breathe partly through their skin, the infection stops them from getting oxygen. They suffocate. Entire forests that once echoed with frog songs fell silent. The fungus spread from continent to continent, killing millions of animals. It is considered one of the worst disease outbreaks in history. Even today, scientists are racing to save species that are on the edge of extinction because of this fungus. The story is a reminder that fungi are not always helpful. They can be destroyers as well as recyclers. Something microscopic and invisible can reshape entire ecosystems. It shows the hidden power of the fungal kingdom and how much we still have to learn about the delicate balance of life. Fact 14. The air you breathe is full of mushroom spores. Right now, as you read this, you are breathing in mushroom spores. They are floating all around you. Spores are the tiny seeds that mushrooms release to grow new fungi. They are so small you cannot see them, but they are everywhere. Billions of spores drift through the air at any given moment. They float in cities and forests. They rise into the sky and fall with rain. Scientists estimate that every breath you take contains thousands of spores. Your body is used to this. Your immune system deals with them without you ever noticing. Spores are one of the most common particles in Earth's atmosphere. They travel on wind currents for thousands of miles. A spore released from a mushroom in a forest might float across an entire ocean before landing on the other side of the world. In a way, every breath connects you to distant forests and ecosystems you will never see. You're always breathing in the invisible presence of mushrooms. The fungal kingdom is always with you, floating silently through the air. Fact 15. Spores are so light they can float in the stratosphere. Mushroom spores are built to travel. They are incredibly tiny and lightweight. Some are so small that they can float more than 20 miles above the surface of the Earth. That is higher than airplanes fly. Up in the stratosphere, spores drift on high-altitude winds. They can stay in the air for months, crossing continents and oceans. Spores have tough coatings that protect them from ultraviolet radiation, extreme cold, and dryness. This allows them to survive journeys that would kill most living things. Imagine a single spore released from a puffball mushroom in a meadow. It floats upward, caught by a breeze. It rises higher and higher until it is miles above the earth. It drifts across countries. Eventually it settles back down on the other side of the planet where it finds soil and water and begins to grow. Spores turn the atmosphere into a highway. They connect ecosystems across the entire globe. The sky is full of invisible travelers carrying life from one place to another without ever stopping, without ever resting. Fact 16. Some spores can survive a trip through space. Scientists have done experiments where they exposed fungal spores to the harsh conditions of outer space. No air, deadly radiation, extreme cold. Most life would be destroyed immediately, but many spores survived. They floated outside spacecraft for weeks. When brought back to Earth, they were still alive and could still grow. This incredible toughness suggests that life might be able to travel between planets. If spores can survive in space, maybe they could hitch a ride on a meteorite. Maybe life could spread from one world to another carried by these tiny survivors. This idea changes how we think about life in the universe. Maybe Earth is not the only place with mushrooms. Maybe fungal spores are drifting through the galaxy right now, waiting to land on a new planet. When you see a mushroom releasing a cloud of spores, you are watching a survival strategy so powerful it might work beyond our world. These are explorers. These are pioneers built to endure the impossible. Fact 17. Mushrooms can break down stone over time. We think of rock as permanent and unchanging, but even stone can be broken down by mushrooms. Some fungi secrete acids that dissolve minerals. Over centuries, these fungi can turn solid rock into soil. This process is how mountains eventually become fertile ground where plants can grow. Without fungi, the world might still be covered in bare rock, with no soil to support forests or fields. In a sense, fungi are the gardeners of the earth. They prepare the ground for all other life. Even today, if you look at old stone walls or ancient ruins, you will see patches of fungus and lichen slowly eating into the rock. They work with patience measured in hundreds of years. Bit by bit, they reshape the bones of the planet. They prove that nothing is truly permanent. Even stone yields to the quiet persistence of fungal threads. What looks eternal is actually temporary. Given enough time, mushrooms can reshape the world. Fact 18. Certain fungi create fairy rings in meadows. Sometimes after rain, you will see mushrooms growing in a perfect circle in a field or meadow. People used to believe these circles were made by fairies dancing at night. They called them fairy rings. The truth is almost as magical. These rings form because a single fungus spreads outward underground in all directions. The mushrooms you see above ground are just the tips of the mycelium as it advances. Each year the circle gets a little bigger as the fungus grows outward. Some fairy rings are hundreds of years old and can be dozens of feet across. In folklore, stepping inside a fairy ring was dangerous. People said you might be trapped in the fairy world or cursed with bad luck. Today we know the rings are natural, but the sense of wonder remains. There is something beautiful about a perfect circle of mushrooms drawn by invisible threads in the grass. It feels like a message from another world, a living symbol of geometry and growth written into the landscape by forces we cannot see. Fact 19. Some mushrooms can appear overnight after rain. One day the ground looks empty. The next morning it is covered with mushrooms. This sudden appearance has always seemed magical to people. How can something grow so fast? The answer is that the mushroom was already there, hidden underground. The mycelium has been growing for months or even years, storing energy and waiting. When rain falls and the soil becomes moist, the mushroom pushes up through the ground incredibly quickly. Some mushrooms can grow several inches in just a few hours. They unfold like tiny umbrellas opening in fast motion. This sudden emergence has given mushrooms a mystical reputation throughout history. People thought they were conjured by spirits or appeared by magic. But the truth is just as amazing. Years of invisible preparation lead to one spectacular moment. The mushroom was patient. It waited for the perfect conditions. And then it burst into the light as if from nowhere. The next time you see mushrooms after a storm, remember they were always there beneath your feet, waiting quietly for the signal to rise. Fact 20. Mushrooms have been used as natural dyes for cloth. Long before chemical dyes were invented, people discovered that mushrooms could colour fabric. Different mushrooms produce different colours. Some make bright yellows and oranges. Others create deep purples or reds. A few can even make blue or green. dyers would gather mushrooms from the forest and boil them with wool or silk. The pigments in the mushroom would stick to the fabric, creating beautiful and lasting colours. Each mushroom species has its own unique shade. Some colours shift and change depending on the light. These natural dyes are still used today by artists and craftspeople who want to avoid chemicals. They celebrate mushrooms not just as food or medicine, but as painters of colour. Imagine wearing clothing dyed with mushrooms, carrying the hues of the forest with you wherever you go. The colours are subtle and rich. They connect the person wearing them to the earth in a quiet, beautiful way. Fact 21. Some fungi can trap and eat tiny worms. Most mushrooms are gentle recyclers, breaking down leaves and wood, but some are hunters. Certain soil fungi have evolved ways to catch and eat nematodes, which are tiny worms that live in the dirt. These fungi build microscopic traps. Some traps are sticky nets, others are loops that tighten like lassos when a worm touches them. Once caught, the fungus pierces the worm and absorbs its nutrients. This hunting strategy allows the fungus to get extra food in poor soil, where there are not many nutrients. To think of a mushroom as a predator is strange. We usually imagine hunters as animals with teeth and claws. But here in the soil there are invisible battlefields where fungi lay traps and capture prey without moving, without eyes, without thought. It is survival refined to its simplest form. The fungus waits. The worm passes by. The trap closes. Life feeds on life in ways we never see. Fact 22. Mushroom mycelium can be stronger than steel. Mushrooms look soft and fragile, but the threads of mycelium can be incredibly strong. When woven together into a dense mat, mycelium creates a material that can be tougher than steel when measured by weight. Scientists have tested mycelium and found it can support enormous pressure without breaking. This strength combined with how light it is has made fungi interesting to engineers and designers. People are now using mycelium to make building materials, furniture, and even packaging. These materials are strong, fireproof, and completely biodegradable. When you're done with them, you can compost them, and they will return to the earth. Imagine building a house not from bricks and steel, but from living fungal threads. Imagine furniture that grows instead of being manufactured. The mushroom you see in a forest might look delicate, but its architecture is extraordinary. It is built from fibres that are humble in appearance but astonishing in strength. Fact 23. Fungi were among the first organisms on land. Before trees, before flowers, before grass, there were fungi. Fossil evidence shows that fungi colonized land over 1 billion years ago. They were among the first living things to leave the ocean and settle on bare rock. They helped break stone into soil, making it possible for plants to follow. Some scientists believe enormous fungal towers once stood on the land hundreds of millions of years ago. These giants, called prototaxites, might have been over 20 feet tall. They were the tallest living things of their time, rising like strange pillars in a world without forests. Imagine walking across a barren landscape where giant mushroom spires dotted the horizon. No trees, no grass, just rock and fungi preparing the world for what would come next. Without these ancient pioneers, Earth might never have become the green, fertile planet we know. Fungi paved the way. They were the quiet architects of life on land. Fact 24. Some mushrooms are so small they fit on the head of a pin. Not all mushrooms are large enough to pick and hold in your hand. Some are so tiny they are almost invisible. These miniature mushrooms grow on dead leaves or twigs, and can only be seen clearly through a magnifying glass. They are no bigger than grains of sand. Despite their size, they still perform the same essential work as larger mushrooms. They break down matter and release spores. They help recycle nutrients back into the soil. Many of these micro-mushrooms are incredibly beautiful. Under magnification, they look like tiny glass sculptures with delicate caps and stems. To know that such small, fragile creatures exist all around us is humbling. The forest is not only filled with large mushrooms we can see, it is also full of miniature worlds operating at a scale too small for our eyes. Life exists in every size, from the gigantic to the microscopic. Fact 25. Others can grow to be larger than a human. At the opposite extreme, some mushrooms grow enormous. The giant puffball mushroom can swell to the size of a soccer ball or even larger. Some weigh over 20 pounds. When they mature, a single puffball can release trillions of spores in a huge smoky cloud. In tropical forests, bracket fungi cling to tree trunks and can grow several feet wide, big enough to sit on. These giant mushrooms have inspired stories and folklore for centuries. People who found them thought they were creatures of myth. To stand before a mushroom as large as yourself is to feel wonder and a little bit of awe. Here is something that grew from the bark of a tree, yet it rivals you in size. Mushrooms stretch across an incredible range, from the nearly invisible to the monumental. They remind us that the fungal kingdom contains extremes we rarely imagine. Fact 26. The smell of truffles can drive animals wild. Truffles are special mushrooms that grow underground. They never come to the surface. They have a smell so powerful that animals can detect them from far away. The scent contains chemicals similar to the signals many creatures use to communicate with each other. For pigs especially, the smell is almost impossible to resist. Farmers used to bring pigs into the forest to sniff out truffles because the pigs would go crazy trying to dig them up. Now people use dogs instead because dogs can smell the truffles but will not eat them immediately. Humans also find the smell captivating. Truffles are among the most expensive foods in the world because of their rich, earthy aroma. The scent drifts through the soil and draws animals to dig them up. When an animal eats a truffle, it spreads the spores in its droppings, helping new truffles grow elsewhere. This clever strategy allows truffles to reproduce even though they cannot release spores into the air. Instead, they create a perfume so compelling that entire species are driven to seek them out. The truffle sits underground, silent and hidden, but its smell travels like an invisible message calling creatures from all directions. Fact 27. Mushrooms help trees talk to each other. Deep in the forest, trees are connected to one another through an underground network made by fungi. Scientists call this the wood wide web. Fungal threads wrap around tree roots and extend deep into the soil. Through these connections, trees can share resources with each other. A tree standing in bright sunlight might send extra sugar through the fungal network to a younger tree growing in the shade. If one tree is attacked by insects, it can send chemical warning signals through the fungi to alert nearby trees. Those trees can then prepare their defenses before the insects arrive. This hidden conversation happens all the time beneath our feet. Without fungi, forests would be collections of separate individuals competing for survival. But with fungi, forests become communities where trees help each other and communicate about danger and resources. The next time you walk through woods, imagine the roots below you not as isolated systems, but as parts of one great conversation. Mushrooms act as translators between giants, carrying messages through the soil in a language we're only beginning to understand. Fact 28. The wood wide web connects entire forests. The idea of trees talking through mushrooms sounds like fantasy, but it is real. Scientists have proven that a single fungal network can link hundreds of trees together. Old trees, sometimes called mother trees, can feed their seedlings through this underground web. They send nutrients to their offspring, helping young trees survive in deep shade where sunlight is scarce. When a tree is dying, it can pass its remaining resources through the network, leaving behind a gift for the forest. This web allows a forest to function almost like a single organism. Trees share information about weather, pests, and water. They support weak members. They coordinate responses to threats. What we see above ground as individual trees is only half the picture. Below, in the dark soil, the fungal kingdom weaves everything together into one interconnected system. The forest has a kind of memory and awareness that flows through fungal threads. It is not consciousness the way humans experience it, but it is cooperation on a scale that changes how we understand plant life. Fact 29. Mushrooms can store carbon underground for centuries. One of the most important jobs fungi do is help fight climate change. Through their partnerships with plants, fungi move carbon from the air into the soil. Trees absorb carbon dioxide through their leaves. Some of that carbon gets sent down to the roots and traded to fungi in exchange for nutrients. The fungi then store that carbon in their mycelium or in the soil where it can stay locked away for hundreds of years. This prevents the carbon from returning to the atmosphere as greenhouse gas. Forests are valuable for storing carbon, partly because of the fungal networks beneath them. Even when fungi break down dead wood and leaves, they control how quickly carbon is released back into the air. In a time when climate change threatens the planet, the humble mushroom working silently underground might be one of our best allies. Fungi are capturing carbon with every breath the forest takes. They are balancing the cycle. They are keeping excess carbon out of the sky. and tucked safely into the earth where it belongs. Fact 30. Some mushrooms grow only on animal dung. As strange as it sounds, certain mushrooms thrive in places most people find disgusting. They grow directly from the droppings of cows, horses, and other animals. These mushrooms include species with names like inkcaps. To a mushroom, dung is treasure. It is full of nutrients that have already been broken down by the animal's digestive system. Fungi can easily absorb what remains and turn it into energy. By recycling dung, these mushrooms complete the circle of life. They transform waste back into fertile soil. Some of these mushrooms even have special abilities to launch their spores incredible distances. They shoot spores away from the dung pile onto fresh grass where grazing animals will eat them. The spores pass through the animal's body unharmed and come out in new dung ready to grow again. What seems unpleasant to us is, to fungi, an opportunity. In their world, nothing is wasted. Even the most unlikely materials become resources. Everything serves a purpose in the endless recycling of life. Fact 31. Others appear only after a forest fire. Some mushrooms wait patiently for disaster before they emerge. These are called fire-loving fungi. They remain hidden in the soil sometimes for years until flames sweep through the forest. Fire clears away vegetation and leaves behind layers of ash. The heat and chemicals from the fire change the soil in ways these special mushrooms need. Then, as if by magic, mushrooms like morels begin to sprout in great numbers. People who know about this will search burned forests for these prized mushrooms. Morels are treasured for their honeycomb caps and rich flavour. But beyond human interest, these fire-following fungi play an important role in helping ecosystems recover. They quickly recycle nutrients from the ash and prepare the ground for new plants to grow. Where flames have destroyed, mushrooms rise to transform loss into the beginning of renewal. They are the first responders of the forest. They turn devastation into fertile ground. In their quiet way, they prove that even after fire, life finds a path forward. Fact 32. Certain mushrooms contain natural antibiotics. Long before modern medicine existed, fungi were already producing chemicals to fight bacteria. Many of these compounds turned out to be useful for humans too. Penicillin, the first widely used antibiotic, came from a mold closely related to mushrooms. It has saved millions of lives, but mushrooms themselves also contain antimicrobial substances. Scientists are studying these compounds as potential new treatments for infections. In the wild, these chemicals help fungi survive in environments full of competing bacteria and other microbes. For us, they represent hope. Solutions to diseases might be hiding in the forest, waiting to be discovered in a mushroom growing on a fallen log. Each mushroom is like a tiny laboratory, producing chemicals not just for its own survival, but potentially for healing creatures far beyond its world. The connection between fungi and medicine goes back thousands of years, and continues today as researchers search for the next breakthrough hidden in fungal chemistry. Fact 33. Without fungi, bread and beer would not exist. Every time you eat a slice of bread or drink a beer, you are tasting the work of fungi. Yeast is a tiny single-celled fungus that transforms sugar into alcohol and carbon dioxide. This process is called fermentation. In bread, the carbon dioxide gets trapped in the dough and makes it rise, creating soft, fluffy loaves. In beer and wine, the alcohol is what we drink. Without yeast, human cuisine would be completely different. No pizza dough, no champagne, no warm rolls. Archaeological evidence shows that humans have been using yeast for thousands of years. Ancient people probably discovered fermentation by accident, when wild yeast floating in the air landed on crushed fruit or wet grain. Over time, people learned to control and cultivate yeast. These microscopic fungi became partners in civilization. They shaped culture, economy, and celebration. When you tear open a loaf of bread, you're experiencing the invisible work of billions of fungal cells that lived, ate, and created the texture and flavor you enjoy. Fact 34. The yeast used in baking is a fungus. It is easy to forget that yeast is alive. Those little granules you sprinkle into dough are living organisms. They are fungi, cousins of the mushrooms that grow in forests. Yeast cells are too small to see without a microscope, but they are busy and powerful. They feed on sugar and multiply quickly. As they eat, they release gases that make dough puff up and expand. Modern yeast strains have been carefully bred over generations to work well in kitchens and breweries, but they are still members of the fungal kingdom. In every loaf of bread, every bottle of wine, there is a story of partnership between humans and fungi. Billions of yeast cells working together, turning sweetness into substance. They remind us that some of the most important relationships in our lives are with creatures we never see, invisible helpers that have been with us since the beginning of cooking and farming. Fact 35. Some mushrooms can bleed red liquid. Walking through the forest, you might find a mushroom that looks like it has been injured. Bright red drops bead on its cap like blood. One famous example is called the bleeding tooth fungus. Despite its unsettling appearance, the red fluid is not blood. It is a thick liquid full of pigments and other chemicals. Scientists are not completely sure why the mushroom produces this red ooze. It might help the fungus stay moist, or protect it from bacteria and insects. To encounter a bleeding mushroom feels eerie. It looks wounded. It looks alive in a way that makes you uncomfortable. These mushrooms remind us that nature sometimes imitates forms we recognize in strange and unexpected ways. The forest holds secrets that were not designed for human eyes. We are just visitors passing through a world where even mushrooms can seem to bleed. Fact 36. Others smell exactly like rotting flesh. Some mushrooms survive by being repulsive. They are called stinkhorns, and they smell almost exactly like dead animals. The odour is so strong it can make people gag. But this terrible smell has a purpose. It attracts flies and beetles that normally feed on rotting meat. The insects land on the mushroom thinking they have found food. Instead, they get covered in sticky spores. When the insects fly away, they carry the spores to new locations. The mushroom has tricked them into being delivery workers. To humans, the stench is overwhelming. In some cultures, people believed stinkhorns were signs of evil spirits because of their sudden appearance and foul smell. But in reality, they are simply clever survivors. They have evolved to use scent as a tool. In the stillness of the forest, a sudden smell of decay might not mean death at all. It might just be a mushroom playing a trick on every creature passing by. Fact 37. Fungi can create entire underground cities. When mycelium spreads beneath the soil, it does not grow randomly. It forms complex, organized networks that resemble cities. There are main highways where nutrients flow quickly. There are smaller side roads branching off. Some areas act like storage centers where fungi keep reserves for hard times. Other spots function like marketplaces where fungi and plant roots exchange resources. Scientists using special imaging technology have discovered that these networks show remarkable efficiency. They optimize their pathways much like engineers design road systems. While we build cities above ground with concrete and steel, the fungal kingdom constructs hidden metropolises below. These underground cities are alive with activity. Billions of organisms cooperate and trade and communicate. The soil beneath our feet is not empty. It is full of architecture and society and purpose. A civilization of threads that has been building and expanding for millions of years. Fact 38. Some mushrooms can change colour when touched. In the fungal world, things are not always what they seem. Certain mushrooms transform when you handle them. One striking example is a type of mushroom that turns bright blue when its flesh is exposed to air. The change happens because chemicals inside the mushroom react with oxygen. For people who collect mushrooms, this colour change can help identify which species they have found. The transformation is beautiful. A plain-looking mushroom suddenly reveals a hidden blue heart. In folklore, mushrooms that change colour were thought to be magical or enchanted. People believed they held secret powers. Today we understand the chemistry, but the sense of wonder remains. To touch a mushroom and watch it turn blue feels like uncovering a mystery. It reminds us that even in something as simple as a mushroom, there are layers of secrets waiting to be revealed through the gentlest interaction. Fact 39. There are mushrooms that smell like maple syrup. Not all mushroom scents are earthy or unpleasant. Some release fragrances that smell like dessert. The candy cap mushroom, for example, smells almost exactly like maple syrup. When dried, the aroma becomes even stronger, filling rooms with sweetness. Chefs use these mushrooms to flavour cookies, ice cream, and other desserts. The smell comes from special compounds that trick our senses into thinking of pancakes and sugar. To find one in the wild is like discovering a hidden kitchen in the forest. The mushroom sits quietly among leaves and twigs, releasing a scent of breakfast into the air. It is a reminder that fungi are masters of chemistry. They create compounds that can repel, attract, confuse, or delight. From the stench of death to the perfume of maple syrup, mushrooms compose an invisible symphony of smells. Each scent is a note in the chemical language they use to survive and thrive. Fact 40. Some mushrooms smell like coconut or almonds. The variety of mushroom scents is astonishing. Certain species carry aromas of coconut, almonds, or even sweet marzipan. These fragrances are created by compounds that happen to match the smells of foods we recognize. For mushroom hunters, smell becomes an important tool for identification. An almond-scented mushroom might be one species. A coconut-scented one might be something completely different. These aromas can attract animals or insects, helping the mushroom spread its spores. For humans, they create moments of surprise and pleasure. Imagine kneeling in a forest and catching a whiff of coconut from a mushroom growing on a tree trunk. It feels out of place, like the tropics have invaded the woods. But it is just another example of how fungi play with chemistry, in ways that overlap with our memories and kitchens. The forest becomes a place where familiar comforts appear in unexpected forms. Fact 41. Mushrooms are packed with vitamin D. Very few foods naturally contain vitamin D, but mushrooms have a special ability. They can make their own vitamin D when exposed to sunlight, just like human skin does. Ultraviolet light hits the mushroom and converts compounds inside it into this essential nutrient. Vitamin D helps our bones stay strong. It supports our immune system. It can even affect our mood. A handful of mushrooms that have been dried in the sun can contain as much vitamin D as a supplement pill. Some cultures have known this for a long time. They would place freshly picked mushrooms in sunlight before eating them to boost their nutritional value. It is remarkable that mushrooms and humans share this ability. Both of us rely on the same chemistry involving light. In the dim forest, mushrooms may not get much sun, but when they do, they store its energy and become not only food, but medicine. Fact 42. Certain mushrooms contain natural toxins that glow. In some fungi, poison and light combine in strange ways. There are mushrooms whose toxins create a glow. These bioluminescent mushrooms emit soft green or blue light through chemical reactions. Scientists think the light might serve multiple purposes. It could warn predators that the mushroom is dangerous. It could attract insects to spread spores. The glow is most visible at night when patches of forest floor seem to shimmer with faint ghostly light. To see such a sight is both beautiful and unsettling. Here are mushrooms that are dangerous to touch yet radiant as if lit from within. In old stories, people took glowing fungi as signs of spirits or supernatural presence. Their eerie shine hinted at forces beyond the everyday world. Science explains the chemistry, but the wonder persists. Life finding ways to turn danger into luminescence, defense transformed into art. Fact 43. The deathcap mushroom has no cure. Among all poisonous mushrooms, the deathcap is the most feared. It looks ordinary and harmless. Pale greenish cap, white stem. Nothing about it screams danger. But inside it carries a toxin called amatoxin, one of the deadliest substances in nature. Just half of one mushroom cap can kill an adult human. The worst part is that symptoms may not appear for many hours. By the time you feel sick, the poison has already damaged your liver and kidneys. There is no antidote. Doctors can provide supportive care and sometimes perform liver transplants, but survival is uncertain. Throughout history, this mushroom has caused countless deaths. Kings, emperors, and ordinary people have all been victims. The fact that such lethal danger hides in such a fragile form is sobering. It reminds us that nature does not care about our intentions. Beauty and terror exist side by side. A mushroom growing peacefully under a tree might carry within it enough chemistry to end a life. Fact 44. A mushroom once saved the world from a disease outbreak. In the 1800s, diseases like cholera killed millions of people. There were no antibiotics. Doctors were desperate for treatments. One unlikely hero came from the fungal kingdom. A fungus related to the ones that later gave us penicillin showed the ability to stop certain bacteria. The discovery was not fully understood at the time, but it planted a seed. Later, when scientists discovered penicillin, they realized that fungi carried powerful medicines. That breakthrough changed human history. Diseases that once meant certain death became curable. Imagine entire cities living in fear of infection, then finding relief in the growth of a simple mold. Fungi stood between humanity and some of its worst enemies. The story is a quiet reminder that mushrooms and their relatives have saved more human lives than we can count. They are healers working on a scale we are still discovering. Fact 45. Fungi can remember past conditions. It may sound impossible, but fungi appear to have a form of memory. In laboratory experiments, researchers exposed fungal networks to certain environmental changes like shifts in temperature or moisture. Later, when those same conditions returned, the fungi responded differently than they did the first time. They adapted more quickly. They seemed to learn from experience. This memory is not like human thought. It is biological information stored in the network. Such adaptability helps explain why fungi are so resilient. They respond to patterns. They adjust based on history. To walk through a forest is to walk through a landscape where the soil itself remembers. Networks of fungi recall storms, droughts, and seasons. They carry the past in their threads and use it to prepare for the future. The earth beneath us is not just alive. In its own way, it is aware. Fact 46. Some mushrooms can survive freezing solid. Winter can be brutal. Temperatures drop below freezing. Water turns to ice. Most living things either die or go dormant. But certain mushrooms can freeze completely solid and still survive. Their cells contain special compounds that act like antifreeze. These chemicals prevent ice crystals from forming in ways that would tear the mushroom apart. When warmer weather returns, the mushroom thaws and continues growing as if nothing happened. Some species even fruit in the middle of winter, pushing small caps through snow and ice. Their toughness is extraordinary. It means mushrooms can colonize environments as harsh as Arctic tundra and mountain peaks. To find a mushroom growing through snow is to witness defiance. Life quietly enduring conditions that would stop most plants. They are reminders that even in the coldest, bleakest places, the fungal kingdom continues its work. Fact 47. Mushrooms have been used in traditional medicine for thousands of years. Across every continent and culture, humans have turned to mushrooms for healing. In China, the reishi mushroom is called the mushroom of long life, and has been used in medicine for over 2,000 years. In Japan, shiitake mushrooms were once reserved for royalty as a health tonic. Indigenous peoples in Siberia, Africa, and the Americas all developed their own mushroom medicines. They made teas, powders, and poultices using fungi to treat wounds, fevers, and exhaustion. Modern science is now confirming what ancient healers knew through experience. Mushrooms contain compounds that boost the immune system, reduce inflammation, and even show promise against cancer. When you drink mushroom tea today, you are part of a tradition that stretches back millennia. A bond between humans and fungi built from necessity, observation, and respect. Fact 48. Lion's mane mushroom can help regrow nerve cells in animals. The lion's mane mushroom looks like a white waterfall of icicles hanging from a tree. But its appearance is not the most remarkable thing about it. Studies with animals have shown that compounds in lion's mane can stimulate the growth of nerve cells. These compounds encourage the brain to produce something called nerve growth factor, which is crucial for repairing and maintaining neurons. This discovery has excited scientists who study diseases like Alzheimer's and Parkinson's. For centuries, lion's mane has been used in traditional medicine as a tonic for the brain. Now modern research is uncovering why. Imagine a mushroom soft and delicate as frozen mist, carrying inside it the potential to heal the most complex organ in the human body. It is a reminder that answers to our deepest medical challenges might still be waiting in the forest, hidden in plain sight. Fact 49. Some mushrooms release their spores in a puff of smoke. Puffball mushrooms have a special kind of magic. When they mature, their round bodies fill with millions of spores. All it takes is a raindrop, a footstep, or a gentle touch to trigger the release. The mushroom erupts in what looks like a burst of smoke. What appears to be smoke is actually a cloud of microscopic spores, each one a seed of possibility. For children and curious adults, puffballs are a source of delight. Step on one and watch it explode in a satisfying poof. But this is also survival strategy. In one moment, trillions of spores launch into the air, carried away by wind to distant places. To see a puffball release its spores is to witness life's persistence disguised as a simple trick. a cloud of possibility drifting into the unknown. Fact 50. Fungi help decompose every fallen leaf in a forest. When autumn comes and leaves carpet the ground, fungi begin their patient work. Without them, forests would suffocate under layers of dead material. Fungi produce powerful enzymes that break down cellulose and lignin, the tough compounds that give plants their structure. What looks like slow decay is actually an elegant system of recycling. Nutrients locked in those dead leaves are released back into the soil where new plants can use them. Every flower that blooms in spring, every tree that grows tall depends on this process. Fungi are the caretakers of the forest. They ensure nothing is wasted. Death becomes life again through their invisible labour. When you walk through autumn woods, you are crossing an unseen factory where fungi work endlessly to clear the way, dissolving yesterday into tomorrow's growth. In their silence and patience, they keep the earth breathing. Fact 51. Without fungi, life on Earth would not be possible. Imagine if all the mushrooms and fungi suddenly disappeared. Within months, forests would begin to die. Dead leaves and fallen trees would pile up endlessly with nothing to break them down. The ground would become buried under its own debris. Nutrients would be locked away in dead matter, unavailable to plants. Without fungal partnerships, most trees could not absorb enough minerals from the soil to survive. Crops would fail. Ecosystems would collapse. Even the oxygen we breathe depends partly on fungi because they sustain the forests and plants that produce it. Fungi are the recyclers, the partners, the hidden engineers of Earth. They work unseen, but their absence would be catastrophic. Every meal you eat, every breath you take, every green landscape you enjoy exists because fungi are there maintaining the balance. To understand this is to realize that mushrooms are not background characters in the story of life. They are the foundation. Without them, the stage would be empty and the play of life could never begin. Fact 52. Some mushrooms are invisible until nightfall. During the day, certain mushrooms blend completely into their surroundings. They look like ordinary pieces of bark or dead leaves, but when darkness arrives, they reveal their secret. These bioluminescent fungi begin to glow softly in shades of green, blue, or pale yellow. They emerge from the shadows like ghostly lanterns scattered across the forest floor. The glow comes from chemical reactions inside their cells, similar to how fireflies create light. Some species glow only at night to conserve energy during daylight hours. To stumble upon glowing mushrooms in a dark forest is to feel you have crossed into another realm. For centuries, travellers told stories of mysterious lights in the woods, blaming spirits or magic. Today we know the lights come from mushrooms, but they still inspire wonder. The forest has its own illumination system, switched on only when stars appear overhead. Fact 53. Fungi can farm algae to make lichens. Lichens are those colourful crusts and frills you see on rocks, trees and gravestones. They look like single organisms, but actually they are partnerships. A fungus teams up with algae or bacteria. The fungus provides structure and protection. The algae make food through photosynthesis using sunlight. Together they create something neither could build alone. Lichens can survive in extreme places where nothing else grows. Arctic tundra, bare mountain cliffs, even the vacuum of space. They are among Earth's oldest and toughest pioneers. They break down rock into soil, preparing the way for other plants. In a sense, fungi are not just scavengers. They are also farmers, cultivating partners in one of nature's earliest examples of cooperation. Each lichen is a story of teamwork, proof that survival often comes not from fighting, but from joining forces across different kingdoms of life. Fact 54. Certain mushrooms are edible only once cooked. Not all mushrooms can be eaten raw. Some contain mild toxins or compounds that are hard to digest. Heat neutralizes these chemicals and makes the mushrooms safe. Morel mushrooms are a famous example. They are prized by chefs for their nutty, earthy flavour, but eaten raw they can cause stomach upset. Once cooked, they transform into delicacies. Other mushrooms like shiitakes release richer flavours and nutrients only when heat unlocks their chemistry. It is almost as if fire completes their purpose, turning something questionable into something nourishing. For people who gather mushrooms, this knowledge has been passed down through generations. The right preparation turns potential danger into delight. The transformation feels almost magical. Cooking converts uncertainty into sustenance, reminding us that food is not always straightforward. Sometimes it requires respect, knowledge, and ritual to unlock what lies hidden inside. Fact 55. Some mushrooms are so bitter they cannot be eaten. Not every mushroom wants to be food. Some defend themselves with flavors so intensely bitter that even the hungriest animal will reject them. The bitter bolete, for instance, looks almost identical to edible relatives, but one bite delivers a taste so harsh it can ruin an entire dish. These defensive compounds discourage predators without requiring poison. To humans, bitterness is often a warning, a signal from our senses telling us to stop. In the fungal kingdom, it is one more tool for survival. Yet even these unpalatable mushrooms serve important purposes. They still recycle nutrients. They still feed the soil. They remind us that not everything in the forest exists for human benefit. Taste itself is part of the conversation between species, a quiet negotiation that determines who eats and who is left undisturbed. Fact 56. Fungi can create natural substances that alter the mind. Among the most famous and controversial mushrooms are those containing psilocybin, a compound that profoundly changes human perception. These chemicals can create visions, alter the sense of time, and produce feelings of connection beyond the self. For thousands of years, such mushrooms were used in spiritual ceremonies. People believed they opened doorways to sacred knowledge. In recent years, scientists have begun studying these fungi again, investigating their potential to treat depression, anxiety, and addiction. The fact that a mushroom can change consciousness so deeply is remarkable. It suggests that fungi not only recycle forests, but can also rewire the human mind. Whether seen as sacred, dangerous, or therapeutic, these mushrooms sit at the intersection of biology and mystery. They carry within their fragile caps the power to shift how we perceive reality itself. Fact 57. Ancient cave paintings may show mushroom use. In caves across Spain and parts of North Africa, prehistoric paintings show human figures holding objects that look like mushrooms. Some scholars believe these are evidence that early humans gathered mushrooms not just for food, but for spiritual experiences. The images show dancing figures, bursts of pattern, and symbols that echo the kinds of visions certain mushrooms can produce. While we cannot be certain of their meaning, the possibility is fascinating. It suggests humans have been exploring fungal states of consciousness for tens of thousands of years. Perhaps mushrooms shaped culture, ritual, and imagination since the very dawn of art. To think of ancient people gathered around firelight, painting mushrooms on cave walls as symbols of journeys into the unseen, creates a deep connection across time. Fungi may have always inspired both survival and story. Fact 58. Mushrooms can be used to make packaging that breaks down naturally. In a world drowning in plastic waste, fungi offer hope. Mycelium can be grown into molds to create lightweight packaging materials. Once dried, the material resembles foam but is completely natural. After use, it can be composted and will return harmlessly to the soil within weeks. Companies are already using mushroom packaging to replace styrofoam in shipping boxes and product protection. The process uses agricultural waste as food for the mycelium, making it renewable and abundant. Imagine receiving a package cushioned not by plastic that lasts centuries, but by mushroom material that disappears back into the earth. Where synthetic materials cling stubbornly to landfills, fungi promise a cycle of creation and return. Packaging itself could one day become part of the natural flow of life, grown rather than manufactured, dissolving rather than accumulating. Fact 59. Some mycelium acts as a natural barrier against fire. Researchers have discovered that certain types of mycelium resist flames naturally. Unlike plastics or wood that ignite and produce toxic smoke, mycelium materials char and smoulder without dangerous gases. This makes them promising for insulation, furniture, and building materials. Imagine walls lined with fungal networks that not only provide structure but also protect homes from fire. The secret lies in the tough compounds of fungal cell walls which resist burning. Nature through fungi has designed a material humans are just beginning to appreciate. Mycelium fireproofing could revolutionize construction, making buildings both safer and more environmentally friendly. To realize that the same thread stitching together a forest floor could also shield a house from flames reveals the versatility of fungi, a quiet kingdom offering tools we desperately need for a sustainable future. Fact 60. Mushrooms could replace leather with mycelium material. Leather has been valued for centuries for its durability and flexibility. but producing it requires enormous resources and often involves cruelty to animals. Now there is an alternative grown from fungal mycelium. Mycelium leather can be cultivated in sheets, then treated and finished to look and feel like traditional leather. The result is strong, breathable, and entirely natural. Designers are creating shoes, bags, and furniture from this innovative material. Unlike animal hides, which take years to produce, mycelium leather can be grown in weeks with far less water and environmental impact. Its texture can be adjusted to be soft like suede or smooth like polished hide. To think that the same network-forming mushrooms can also become a jacket or chair is remarkable. Fungi are not only healers and recyclers, but inventors, offering humanity materials that balance beauty, ethics, and sustainability in ways we desperately need. Fact 61. Certain mushrooms contain compounds that prevent freezing. In forests where winters are harsh, some mushrooms carry secrets for survival. They produce proteins and sugars similar to antifreeze. These compounds lower the freezing point of water inside their cells, preventing ice crystals from forming and tearing delicate tissues. In the soil, this allows fungi to continue breaking down leaves and wood when most organisms lie dormant. More remarkable still, these molecules sometimes seep into the surrounding environment, loosening the grip of frost. Scientists are studying these natural antifreezes as models for protecting crops from frost or making roads safer in winter without harsh chemicals. It is humbling to imagine a tiny mushroom, no bigger than your thumb, quietly reshaping its frozen surroundings. Resilience often appears in the smallest, softest corners of life, reminding us that survival takes forms we rarely notice until we look closely. Fact 62. Fungi can extract minerals from solid rock. Though they have no tools or strength, fungi are extraordinary miners. Some species release acids that slowly dissolve stone, unlocking nutrients like calcium, magnesium, and potassium. In doing so, they transform lifeless rock into fertile soil where plants can grow. This process likely began over 1 billion years ago, when fungi first spread across barren landscapes. They paved the way for plants to colonize land. Even today, lichens etch their way across cliffs and ancient monuments, tiny but unstoppable. Over centuries, their work reshapes mountainsides. Scientists now study biomining technologies inspired by fungi, hoping to harvest rare elements with far less environmental damage than current methods. To stand before a rocky cliff and realize it is being eaten molecule by unseen fungal threads is to witness patience transformed into power. Stone that seems eternal is actually temporary. Given enough time, mushrooms reshape the bones of the world. Fact 63. Some mushrooms thrive on radioactive waste. In places where human activity has created contamination, mushrooms sometimes flourish where nothing else can. At sites like Chernobyl, scientists have found fungi growing in rubble soaked with radiation. These fungi contain melanin, the same pigment in human skin, but here it serves a different purpose. Instead of just shielding, it seems to convert radiation into energy through a process called radiosynthesis. Imagine mushrooms performing a kind of photosynthesis, but using deadly radiation instead of sunlight. These discoveries hint at extraordinary possibilities. Fungi might help clean radioactive waste or protect astronauts traveling through the harshness of deep space. In disaster zones, mushrooms remind us that life adapts even to the unthinkable. What we consider poison becomes fuel for them. Proof of nature's astonishing ability to survive where survival seems impossible. They turn danger into nourishment and thrive in ruins. Fact 64. Mushrooms may have helped plants colonize land. When the first plants left the oceans to settle on land, they faced a barren world of rock with no soil and few nutrients. But fossils show they were not alone. Fungi were already there, ready to partner with them. These early partnerships allowed plants to draw minerals from stone through fungal networks in exchange for sugars. Over millions of years, this collaboration created the first thin soils. Without fungi, plants might never have successfully taken root on land. Earth might still be a silent planet of rock and water. Every tree, every meadow, every blade of grass carries the legacy of this ancient partnership. When you walk across a field, you are stepping on ground prepared by fungi hundreds of millions of years ago, a debt written into the very fabric of our planet's living surface that we rarely acknowledge or understand. Fact 65. Some fungi form partnerships with coral reefs. Though we usually think of mushrooms as forest dwellers, fungi also live in the ocean. Marine fungi have been discovered alongside corals, weaving threads into the architecture of reefs. These partnerships may help regulate nutrients, protect corals from diseases, or stabilize fragile reef ecosystems. Though less studied than their land cousins, marine fungi could be crucial to coral survival under the stresses of warming oceans and climate change. To picture fungi drifting among colourful coral is to realise the fungal kingdom knows no borders. It stretches from mountain tops to ocean depths, stitching together life in hidden ways. If corals are the architects of reefs, fungi may be their caretakers, helping them endure harsh conditions. Even beneath the waves, mushrooms and their relatives prove that life is never solitary. It is always built through cooperation and connection. Fact 66. Mushrooms can reproduce both sexually and without partners. Fungi are masters of adaptability. They can release spores without mating, producing countless genetic copies quickly. This strategy allows them to spread rapidly through soil and air with remarkable efficiency. But fungi can also reproduce by exchanging genetic material with others, creating variation. This gives them flexibility to face changing conditions, diseases, or new environments. Some species switch between methods depending on circumstances, maximizing survival chances. Imagine an organism with two completely different approaches to making more of itself. One for speed, one for resilience. It is versatility few life forms possess. Each mushroom you see may be the result of rapid cloning or careful genetic mixing, a visible reminder that fungi hold within them not just one strategy for existence, but many, allowing them to thrive in nearly every environment on Earth. Fact 67. Some species have over 20,000 different mating types. In the fungal world, reproduction takes diversity to extremes. Some species have tens of thousands of compatibility codes equivalent to what we might call gender. The split-gill mushroom may have more than 23,000. These are not genders in the human sense, but genetic keys written into their structure. The result is that nearly any two individuals can mate successfully, maximizing opportunities for reproduction. This system prevents inbreeding and encourages tremendous genetic variety, ensuring resilience across generations. Where humans imagine reproduction as simple, fungi explode the concept into thousands of possibilities. To consider a mushroom's mating system is to glimpse the creativity of evolution itself. For fungi, diversity is not unusual. It is fundamental, woven into their very being. They prove that life does not follow our categories, but creates its own endless variations. Fact 68. A single puffball can release trillions of spores. When a puffball mushroom matures, it transforms into a sphere filled with fine powder. What looks like dust is actually countless microscopic lives. A large puffball can release trillions of spores, more than the number of humans who have ever existed. Most will drift away and land in places too harsh to grow. Yet a few will find the right conditions and begin new colonies. This is survival through overwhelming numbers, scattering so many seeds that some must succeed. Watching a puffball erupt is like seeing the forest breathe, a moment when invisibility becomes visible and possibility scatters into the wind by the millions. Each spore carries the entire blueprint for a new organism, floating on hope and chance toward an unknown future. Fact 69. Spores can be found floating high above cities. The fungal kingdom extends far beyond forests. Spores rise on air currents and drift thousands of feet above buildings and streets. Studies have found them miles above urban areas, mixing with dust and pollen in the atmosphere. Some are swept into clouds and fall later with rain onto distant landscapes. Every breath you take in a city contains traces of spores from faraway gardens, parks, and wild places. Even surrounded by concrete and glass, we remain connected to hidden fungal networks. The air itself bridges wild and urban spaces, carrying spores as constant travellers. Next time you walk down a busy street, remember that the fungal kingdom drifts invisibly overhead, linking your breath to ecosystems you may never visit. Fact 70. Mushrooms may influence weather patterns across the globe. Though invisible, spores may shape something as vast as weather. Tiny and abundant, they rise into the atmosphere where they act as particles around which water droplets form. In this way, fungi may help determine when and where rain falls. Forests may not only recycle nutrients underground, but also call rain from the sky by sending spores aloft to encourage cloud formation. The idea is still being studied, but it suggests mushrooms influence more than soil. They may reach into atmospheric patterns themselves. Imagine raindrops forming around spores released in a distant forest, falling days later across fields and rivers. Fungi blur boundaries between ground and sky, reminding us that life does not stop at borders, but flows upward, outward, everywhere. The connections run deeper than we ever imagined. Fact 71. Certain fungi can absorb heavy metals from polluted soil. In places contaminated by industry, fungi step forward as healers. Some mushrooms have an extraordinary ability to absorb and concentrate heavy metals like lead, mercury and cadmium. Their mycelial threads act like filters, drawing toxins from the environment. This process, called bioremediation, offers hope for cleaning damaged land without machinery or chemicals. Though the mushrooms themselves become unsafe to eat, they serve their purpose by turning poisoned ground into fertile soil again. Imagine a ruined landscape slowly healing as mushrooms work their way through contaminated earth. They are nature's chemists, transforming danger into something contained. In their quiet labour, fungi reveal a template for restoration. Even in the most damaged corners of the world, healing can begin not with technology alone, but with the patient work of threads in the soil. Fact 72. Mushrooms can be used to clean up oil spills. When oil seeps into soil or water, damage can persist for decades, but fungi may offer an elegant answer. Certain mushrooms can break down hydrocarbons, the very molecules that make up petroleum, into harmless substances. Mycelium secretes enzymes that dismantle toxic residue, transforming black sludge into fertile ground where plants can grow again. In experiments, areas treated with fungi have changed from oily wastelands into blooming fields within weeks. This technique suggests mushrooms could help heal some of humanity's greatest environmental disasters. Picture an oil-soaked shoreline slowly turning green again through mushrooms spreading their threads through poisoned ground. Nature holds solutions within the very organisms we often ignore. Where human accidents create lasting harm, fungi offer redemption through patient, invisible work. Fact 73. Some mushrooms taste like chocolate. Mushrooms are usually associated with earthy or savoury flavours, but a few rare species produce aromas and tastes reminiscent of chocolate or cocoa. Scientists believe these flavours come from unique aromatic molecules that mimic sensations chocolate creates on our tongues. Though uncommon, these chocolate-flavoured mushrooms remind us how diverse fungal chemistry can be. Imagine walking through woods expecting damp earth, and catching instead a whiff of something warm and sweet like a bakery hidden among trees. For creative chefs, these mushrooms open strange possibilities, desserts flavoured not with cacao beans but with forest fungi. It is another way mushrooms defy expectations, offering surprises not only in shape and colour, but in tastes that echo human comforts and pleasures. They blur lines between forest and kitchen, wild and familiar. Fact 74. Others glow green like lanterns in tropical forests. In warm, humid forests, certain mushrooms cast an eerie glow, bright enough to illuminate surrounding leaves. These bioluminescent fungi shine with greenish light caused by chemical reactions involving special molecules. Scientists think the light helps attract insects at night, which then carry spores to new locations. To encounter them in darkness is to feel the forest has lit its own lamps along the ground. For centuries, travellers told stories of mysterious lights shimmering from rotting wood. People called it fairy fire or fox fire. Today we understand the chemistry, but the magic remains. Even in darkness, life finds ways to illuminate itself, creating small green beacons that guide spores toward their future. The forest, when night falls, becomes its own constellation. Fact 75. Mushrooms once grew as tall as trees. Hundreds of millions of years ago, Earth looked completely different. Long before towering forests, massive fungi dominated the landscape. These strange organisms, called prototaxites, grew up to 30 feet tall, making them the tallest living things of their time. They rose like pillars in a world where insects had only just begun flying. Fossils suggest these giants resembled enormous tree trunks, yet they were neither plant nor wood but pure fungus. Imagine walking across a prehistoric plain where towering fungal spires stood solitary against empty horizons. They prepared the land for forests to come, breaking down rock and building soil. Today mushrooms are mostly small and brief, but their ancestors once ruled the earth, guardians of a forgotten age when fungi, not trees, were the giants shaping the world. Fact 76. Some fungi can survive complete drying out. Water is considered essential for life, but certain fungi can endure even when every drop is removed from their bodies. Desert fungi and lichens can survive complete desiccation, drying until they appear lifeless and brittle as paper. Their tissues shrivel, their colour fades, they look dead by every measure we understand. Yet when moisture returns, even after years of dormancy, they awaken and resume growth as if nothing happened. This extraordinary resilience comes from special sugars and proteins that protect their cells from collapse during drought. These compounds act like microscopic cushions, preventing the cell walls from crushing inward when water disappears. It allows them to colonize the harshest deserts and bare rocky outcrops where few organisms can exist. Scientists study these fungi for clues about how life might survive on Mars or other dry planets, where water is scarce or absent. Imagine a tiny fungal thread, dormant and fragile for years, brittle enough to crumble between your fingers yet springing back to life with the first touch of rain. In their quiet endurance, these organisms show that survival sometimes means not fighting conditions, but waiting perfectly still until the moment is right. Patience becomes the ultimate survival tool. Time becomes an ally rather than an enemy. The ability to pause life itself, to enter a state between living and dying, gives these fungi access to environments that would destroy organisms dependent on constant moisture. Fact 77. Mushrooms have been sent into space for experiments. The strange toughness of fungi has made them subjects of space research for decades. Scientists have launched mushrooms and fungal spores aboard spacecraft to test survival in microgravity and cosmic radiation. The conditions outside a spacecraft are deadly beyond imagination. No air to breathe, temperatures swinging from boiling to freezing, radiation levels that would kill most organisms instantly. Yet to the amazement of researchers, many fungi not only survived but continued growing. Some species even seem to adapt, changing their chemistry in response to the extreme environment. They produced different pigments, they altered their cell walls, they found ways to cope with conditions no Earth organism should be able to withstand. Such studies hint that fungi could play roles in future space missions, perhaps recycling waste in closed habitats, producing food for astronauts, or even protecting spacecraft from radiation by growing on exterior surfaces. There is speculation that hardy spores might survive journeys between planets, drifting through space for thousands or millions of years, then landing on a new world and beginning to grow. Whether true or not, mushrooms orbiting Earth remind us that life is astonishingly flexible and creative. A mushroom that can grow in the vacuum of space stretches our imagination of where life can thrive, suggesting Earth's hidden kingdom may have potential beyond our planet. Perhaps fungi are already cosmic travelers, spreading from world to world, patient voyagers waiting for the right conditions to bloom again. Fact 78. Certain fungi help crops resist disease naturally. Beneath fields of wheat, corn, and rice, invisible partners are working to protect the plants we depend on. Mycorrhizal fungi live in partnership with plant roots, wrapping around them in intricate patterns, providing nutrients, but also strengthening plants against disease. By stimulating plant immune systems, fungi make crops more resistant to pests and infections that would otherwise destroy entire harvests. In some cases, they directly compete with harmful microbes, blocking them from attacking roots by occupying the same space and consuming the same resources. It is like having a bodyguard living inside your skin, constantly alert for threats. Farmers are beginning to use fungal treatments to reduce reliance on chemical pesticides that poison soil and water. They are learning what nature has known for millions of years, that partnership is stronger than warfare. Imagine crops strengthened not by synthetic sprays that kill everything they touch, but by quiet underground partnerships that have been refined over eons. These relationships remind us that agriculture need not be warfare against nature, but collaboration with it. Just as forests thrive on fungal networks that connect and support every tree, farms of the future may find their greatest strength not in chemicals manufactured in factories, but in the same humble fungi that have nourished plants for millions of years. Partnership, not domination, becomes the path forward. Cooperation, not control, becomes the strategy for feeding the world. Fact 79. Mushrooms are used to produce medicines that save lives. Beyond antibiotics, mushrooms and their relatives are treasure houses of healing compounds that modern medicine is only beginning to fully explore and understand. Substances derived from fungi lower cholesterol, prevent organ rejection in transplants, and even show promise against cancer and other diseases once considered incurable. Lovastatin, a medicine that revolutionized heart treatment and saved millions from heart attacks, comes from fungi. Cyclosporin, vital for transplant patients, and without which organ transplantation would be nearly impossible, was discovered in a soil fungus. Researchers continue scanning the fungal kingdom with renewed urgency, searching for the next breakthrough hidden in forests or meadows, or even in extreme environments like volcanic hot springs. For centuries, traditional healers relied on mushrooms, passing down knowledge through generations about which species healed wounds, which reduced fevers, which strengthened the body against illness. Modern science is revealing just how profound their medicinal powers truly are, confirming ancient wisdom with molecular precision. Each cap, each thread of mycelium may carry a molecule that could one day save countless lives, cure diseases we currently cannot treat, or relieve suffering we do not yet know how to address. To walk through woods is in a sense to wander through a living pharmacy, where cures wait patiently to be discovered, hidden beneath moss and bark inside the quiet chemistry of fungi, working to survive and inadvertently offering us healing. The next great medical breakthrough might be growing right now on a fallen log in a forest you could visit this weekend. Fact 80. The first antibiotic, penicillin, came from a fungus. In 1928, Alexander Fleming noticed something unusual in his laboratory that would change the course of human history. A mold had contaminated a petri dish where he was growing bacteria, and everywhere the mold grew, the bacteria died. This accidental observation led to penicillin, the first widely used antibiotic, which saved millions of lives during World War II and continues saving lives every single day around the world. Though not a mushroom in the traditional sense, the mold belongs to the same great fungal kingdom, a close cousin sharing the same fundamental biology. The discovery of penicillin changed medicine forever, turning once deadly infections like pneumonia, scarlet fever, and infected wounds into treatable conditions. Before penicillin, a simple cut could lead to death. A throat infection could be fatal. Childbirth carried enormous risk of infection. After penicillin, survival rates soared. It is humbling to think such a monumental shift came not from human invention alone, but from the quiet work of a fungus, growing in a forgotten dish, doing what fungi do naturally, defending their territory with chemical weapons. That mold carried within it the power to rewrite medical history, to save more lives than any general or politician ever could. It reminds us that fungi are not only decomposers of forests, but guardians of human survival in ways we never predicted or expected. The next time you or someone you love takes an antibiotic, remember it began with a mushroom's cousin, a humble mold that taught us how to fight back against the microscopic enemies that once killed us by the millions. Fact 81. Fungi make bread rise and wine ferment through ancient processes. Every loaf lifting in an oven, and every glass sparkling in celebration, owes a debt to fungi that stretches back thousands of years. Yeasts, single-celled cousins of mushrooms, consume sugars and release carbon dioxide and alcohol as waste products. In bread dough, those bubbles of carbon dioxide get trapped in the sticky protein web of gluten, swelling the loaf like a slow sunrise captured in flour and water. In wine, the same process becomes transformation of grapes into something entirely new, turning simple fruit juice into complex beverages that have shaped human culture and celebration. A sourdough starter is its own small world, its own tiny ecosystem, with yeasts living alongside friendly bacteria, each adjusting to temperature, humidity, and time. Bakers learn to read its behavior by scent and rhythm, by the way it bubbles and rises, treating it almost like a pet that must be fed and cared for. Vintners speak of terroir, the unique character of wine from different regions, which is partly about local yeasts that give wines their distinctive personality. Fermentation is chemistry, yes, the breaking down of sugar molecules into simpler compounds, but it is also partnership, an ancient alliance between humans and fungi. These microorganisms move sugars toward nourishment and joy, one invisible breath at a time. When you tear bread or sip wine, you taste the ancient alliance between humans and fungi, a bond stretching back to the dawn of civilization, to the moment our ancestors first noticed that grain left wet would bubble and rise, that grapes crushed would become something magical given time. Fact 82. Mushrooms have inspired entire traditions of art and design. From folk embroidery passed down through generations to illustrated field guides painted with scientific precision, mushrooms have crept from forest floors onto canvas, cloth, and page, becoming symbols and subjects for countless artists. Their silhouettes are captivating and instantly recognizable. Domes and frills, gills arranged like cathedral arches, stems rising with the elegant poise of dancers. Art movements borrowed their curves, especially Art Nouveau designers who saw in mushroom forms the perfect marriage of nature and geometry. Botanical illustrators chased their subtle colours, trying to capture the exact shade of a rustler or the delicate gradient on a wax cap. Ceramicists glazed caps in rain-washed shine, creating pottery that echoes fungal forms. Modern designers study the ribbed geometry beneath mushroom caps to create lamps, architectural domes, and lattice screens that are both beautiful and structurally sound. Photographers go low to the ground, lying in damp leaves to capture bioluminescent halos, turning nightwoods into starfields where mushrooms become constellations. Even children's books lean on the mushroom's fairy tale presence, a symbol of surprise and enchantment, doors to luminous worlds hidden just out of sight. The appeal goes beyond appearance and aesthetics. Mushrooms are metaphors for emergence, for hidden realms revealed only when conditions align perfectly. Art returns to them again and again because they are both alien and familiar, strange yet comforting, a visual language whispering look closer, notice more, pay attention to what you usually overlook. Fact 83. Some mushrooms produce ultrasonic sounds as they grow. Fungi have no mouths, no vocal cords, no way to speak as we understand it. Yet researchers using ultrasensitive equipment have detected faint clicks and pops as mushrooms grow and mycelium rearranges fluid and pressure within its tissues. Whether these microsounds are intentional signals, a form of communication between parts of the fungal network, or simply biomechanical releases like the creaking of old wood is still being studied and debated. But the effect is enchanting regardless of the explanation. A forest broadcasting at frequencies we rarely notice. A symphony playing just below the threshold of human hearing. In laboratories, scientists measure electrical pulses flowing through mycelial threads, rhythmic spikes that speed up, slow down, and cluster like syllables in a sentence or notes in a melody. Artists have begun translating these patterns into audible music, turning fungal signals into ambient sound that rises and falls with humidity, light, or touch. The results are eerie and beautiful, like listening to the thoughts of something utterly non-human. Listen long enough, and you begin to imagine a choir beneath the soil, signals coordinating growth, resource sharing, or stress responses. Whether language in any meaningful sense or byproduct of living processes, these rhythms remind us that living structures have tempo and pattern. The mushroom's rhythm is patient, precise, and mostly beyond our hearing, a secret music playing constantly in the soil beneath our feet. Fact 84. Fungi have been found living inside solid rocks, in deserts so dry that wind polishes the landscape to bare stone, where rain might not fall for years at a time. Life retreats into rock itself to find shelter. Endolithic fungi tuck themselves within mineral pores, spaces so tiny they are measured in fractions of millimeters, thin as hair and tough as ancient rope. They survive where temperatures swing wildly between scorching heat and freezing cold within a single day, and where water arrives as rumour more than reality, perhaps a brief fog rolling in at dawn. In Antarctic dry valleys, some of the most extreme environments on Earth, they inhabit translucent quartz, sipping dim filtered light that penetrates just millimeters deep into the stone. Their chemistry is pragmatic and elegant in its efficiency. Acids nibble minerals, slowly dissolving rock to release nutrients. Pigments buffer radiation that would destroy unprotected cells. Metabolism slows to a bare ember, consuming almost nothing, waiting decades if necessary, ready to flare when moisture returns for even a moment. To say life is resilient is too simple and inadequate. Life is ingenious, creative, endlessly inventive. These rock dwellers write their existence in microscopic spaces, proving that habitable zones are broader than we think, that life finds footholds in places we assume are sterile and dead. Open a stone with careful tools and proper magnification and you may find not emptiness, but a city of filaments, a reminder that the frontier of life often begins just beneath the surface of what we consider lifeless. Every rock might be a world. Fact 85. Mushrooms can turn ants into zombies through precise control. An ant wanders beneath a leaf going about its daily business, and a spore lands on its body. A single seed of fungus no bigger than a grain of dust, but that seed knows its victim intimately. Inside the ant's body, the fungus grows like a quiet suggestion, threading through muscles while leaving the brain just functional enough to be steered and controlled. Compelled by chemistry, it cannot resist or understand. The ant climbs to a height perfect for spore dispersal, usually about 25 centimeters above the ground, where humidity and temperature are ideal. It bites down on a leaf vein in a death grip so strong the jaw muscles lock permanently, and there it freezes, no longer moving, no longer eating, no longer anything but a platform. Then the fruiting stalk emerges, breaking through the exoskeleton like a dark flower pushing through concrete, releasing spores over forest paths below where other ants will pass. This is the zombie ant phenomenon, precise as clockwork yet deeply unsettling to witness. It is survival refined to pure strategy, evolution solving the problem of dispersal with surgical precision. By manipulating behavior, the fungus positions its offspring in ideal wind currents at exactly the right height. Nature does not judge or moralize, it strategizes and optimizes, and here strategy becomes choreography, a climb, a bite, a stillness, then a mushroom casting its future into moving air. The ant becomes architecture, its body repurposed entirely for the fungus's reproduction. Fact 86. Cordyceps fungi emerge from insect bodies in strange forms. Cordyceps are the sculptors and artists of the fungal world, turning the small dramas of insect life into eerie still life tableaus that look designed by a surrealist painter. A caterpillar hardens into a platform, its soft body becoming rigid foundation. A beetle becomes launching pad for a slim orange spike that reaches toward light. A spider arrested mid-pose sprouts delicate antlers, frozen in a moment that will last forever. Each cordyceps species specializes in particular hosts, an intimacy evolved over millions of years of coevolution, fungus and insect locked in an ancient dance. Under the surface, invisible to us, enzymes soften tissue. Threads fill hollows. The body is remapped from within, transformed from animal into garden, until the fungus steps into light to fruit and complete its life cycle. The sight unsettles because it blurs categories we rely on to make sense of the world. Animal becomes architecture. Parasite becomes sculptor. Predator becomes artist. Yet cordyceps also returns nutrients to forests, recycling insect bodies back into soil, and controls insect populations, maintaining ecological balance through methods we find beautiful, only after the initial shock passes. To notice one growing from a moth or beetle is to stand both repelled and fascinated, reminded that survival takes forms nature designs without concern for our comfort or approval. Beauty and horror intertwine. Death becomes art. The fungus cares nothing for our reactions. It simply does what it has always done, converting one kind of life into another with ruthless efficiency. Fact 87. Some mushrooms look like tiny bird nests holding eggs. Kneel in damp leaf litter during autumn, and you may discover thimble-sized cups perfectly formed, cradling glossy spheres that look exactly like miniature eggs in miniature nests. These are bird's nest fungi, and those egg shapes are peridials, spore packets ready for a rain-driven journey into the world. When a drop falls from above, it strikes the cup at just the right angle, delivering a precise amount of force, splashing the packets outward like stones from a sling or catapult. A sticky cord trails behind each packet, helping them latch onto passing twigs or animal fur, hitchhiking toward new territory where they might establish new colonies. The design demonstrates perfect physics scaled down to a raindrop, every angle calculated by evolution over millions of years. Impact angle, trajectory, force, adhesion, all optimized through countless generations. They are easy to overlook until you have seen one, tiny and hidden among fallen leaves. Then suddenly the forest becomes full of miniature nests, whole nurseries operating in silence at ground level, waiting for rain. Bird's nest fungi collapse the distance between whimsy and engineering, between fairy tale and physics, a form that looks designed for delight but exists for survival. Each rainstorm becomes a launch sequence for the next generation, a moment of explosive dispersal, triggered by nothing more than falling water. Fact 88. Others look like fingers reaching from the ground. In shaded forest corners where sunlight rarely penetrates, clusters of blunt dark clubs push from soil like a hand half buried and reaching upward. Dead man's fingers they are called with typical human morbidity, blue-grey at first when young, then darkening with age until they look charred or burned. Elsewhere in the same forests, coral fungi lift pale, branching forms in delicate chandeliers, forking and forking again like underwater structures transplanted to land. These shapes trick the eye because they feel expressive and intentional, are reaching or beckoning, when they are simply structures designed by evolution to release spores efficiently into moving air, maximizing surface area to maximize dispersal. The macabre names we give them reflect our tendency to find ourselves in everything we observe, to project human meaning onto forms that have nothing to do with us. Look longer, and the drama quiets. The emotional response fades. These fingers are wood recyclers born from buried roots, marking where a tree once stood, growing from the dead tissue beneath the soil. They rise, disperse spores into wind, and weather back to husks within weeks. But the mycelium beneath persists, patient as bedrock, waiting for the right conditions to fruit again. It is a useful reminder that much of life can be hidden, yet still constitute the truest part of the story. What we see above ground is only the temporary message from something vast and ancient below. Fact 89. Some mushrooms are covered in protective slime. Gleaming caps beaded with moisture are common sights after rain, but some mushrooms are slick even in dry conditions. Some are so covered in viscid coating you could nearly see reflections in their surfaces. This slimy layer is not accident or mere aesthetic, but adaptation shaped by survival pressure. In certain species like boletes, a viscid cap helps retain moisture during dry periods and protects tender tissue from drying winds that would otherwise desiccate them. In the brazen stinkhorns, slime serves a completely different purpose, becoming tool rather than shield. The foul-smelling gel called gleba attracts flies that land, feed on the nutritious coating, and leave wearing spores like powder on their feet, becoming unwitting delivery services. What we perceive as warning or unpleasantness, fungi use as multifunctional toolkit. Hydration layer, raincoat, insect attractant, perfume, billboard announcing availability. Touch one and your fingertips come away tacky and slightly sticky, a tactile reminder that the forest builds on function before appearance, that what looks beautiful or disgusting to us serves practical purposes in fungal survival. Even gloss and shine have jobs to do. In the fungal kingdom, every surface texture, every coating, every colour serves survival in a competitive world where resources are limited and threats are constant. Fact 90. Mushrooms can be bright blue, purple, or pink. Some mornings the forest abandons its usual palette of browns and greens entirely, as if someone came through in the night with paint. Indigo milk caps bleed brilliant blue when cut, staining everything they touch. Amethyst deceivers scatter jewel-bright purple fragments among brown leaves like gemstones dropped carelessly. Wax caps rise in sherbet pinks and citrus yellows on old meadows, so bright they look artificial. The colours serve varied purposes depending on species. Pigments shield delicate tissues from excessive light, preventing damage from ultraviolet radiation. Others act as antioxidants, protecting cells from chemical stress. Some signal to insects that might help with dispersal, while others simply accompany traits selected for other reasons, evolutionary side effects that persist because they cause no harm. To stumble onto a bright blue mushroom creates a jolt of disbelief, a moment where reality seems slightly unreal, like finding tropical fish in a forest puddle, Photographers pursue these moments with dedication, spending hours lying in damp leaves to capture a cobalt, cap beneath moss, a violet stem against russet oak leaves. Colour in fungi represents a spectrum of survival strategies and evolutionary accidents that read as pure wonder to human eyes. The palette reminds us forests are not monotone or dull. They are stained glass windows laid flat on the ground, illuminated from above by filtered sunlight, painted from below by quiet chemistry of soil and survival, creating beauty as a byproduct of staying alive. Fact 91. Fungi can survive in the harshest deserts on Earth. In dry silence where plants curl into thorns to conserve every drop of moisture, and animals vanish into burrows during the day, fungi still persist against all odds. Some hide in cryptic forms, living within rocks as we have seen, shielded from wind and sun. Others cloak themselves in lichens, binding with algae or cyanobacteria to form living skins across stone, creating partnerships where each member provides what the other lacks. These collaborations make food from sunlight, while fungi provide shelter, structure, and moisture storage, pulling tiny amounts of water and sharing it carefully. Even in the Atacama Desert in Chile, one of the driest places on the entire planet where rain might not fall for decades, scientists have found fungal life clinging to salt crystals and mineral veins, surviving on fleeting mists that roll in from the ocean at dawn and dew that forms for a few minutes before evaporating. Their resilience is staggering and humbling. They tolerate extremes of heat that would cook most organisms, cold that would freeze them solid, drought that would desiccate them completely, and radiation levels that would destroy their DNA. To imagine fungi thriving where almost nothing else can is to see survival at its most essential and pure. Life through fungi whispers even in places we call barren wastelands, proving repeatedly that the boundaries of possibility extend far beyond what we assume or imagine based on our own narrow requirements. Fact 92. Mushrooms once fed the dinosaurs millions of years ago. When dinosaurs thundered through ancient forests that looked nothing like modern woods, fungi were there breaking down wood, recycling matter, and sometimes feeding the giants directly. Fossil evidence suggests mushrooms grew abundantly during the Mesozoic era, the age of dinosaurs sprouting in soils rich with decaying vegetation from plants that no longer exist. Some may have been eaten by herbivorous dinosaurs alongside ferns and primitive conifers, their fruiting bodies plucked from the ground like snacks during long days of browsing. Others partnered with tree roots, sustaining the forests dinosaurs depended on for food and shelter. Imagine a massive sauropod stretching its impossibly long neck across a swampy clearing, the ground beneath dotted with mushrooms the size of dinner plates, larger than any you would find today. In a world before flowering plants existed, before grasses covered plains, before most modern trees evolved, fungi were already recycling nutrients and maintaining the cycle of life. They were both food and infrastructure, feeding individuals while supporting entire ecosystems. To think that dinosaurs, those symbols of raw power and dominance, relied partly on humble mushrooms is to realize even giants walk on foundations woven quietly by fungi. Every ecosystem, no matter how dominated by spectacular megafauna, depends ultimately on the small, the overlooked, the organisms working invisibly to keep nutrients flowing. Fact 93. Fossil fungi date back over 400 million years. The fossil record preserves bones and shells readily because they are hard and mineral-rich, but mushrooms leave softer traces that are rare, delicate and easily destroyed. Still, through fortunate circumstances and careful searching, we have found impressions and mineralized remains stretching back over 400 million years into the Devonian period when the world was young. These fossils capture filaments and spores frozen in ancient sediment, time capsules showing us that fungi were already diversified and complex, while fish were only beginning to venture onto shore. They reveal that fungi were shaping land while plants were still primitive and small, while forests as we know them did not yet exist. Some fossils even preserve mycorrhizal partnerships in exquisite detail, proof that even then, hundreds of millions of years ago, fungi were collaborating with plants to colonize bare rock and build soil one molecule at a time. It is humbling and awe-inspiring to hold a piece of stone and know it carries the ghost of a fungus that lived before forests filled the continents, before insects took to the air, before most life had left the sea. Each fossil opens a window into deep time, showing us that fungi are not recent arrivals or minor players but primeval architects present at the very birth of the terrestrial world we inhabit today. They witnessed the greening of the planet. They made it possible. Fact 94. The oldest fungal fossil is nearly 1 billion years old. In the remote Canadian Arctic, far from cities and civilization, scientists discovered fossilized filaments so ancient they challenge and expand our imagination of life's timeline, nearly 1 billion years old. This makes fungi among the earliest complex organisms ever found in the rock record, predating plants by hundreds of millions of years, existing in a world so different from ours it might as well be an alien planet. These filaments preserved in ancient rock reveal that fungi were experimenting with intricate multicellular forms long before forests existed, perhaps even before animals evolved from single-celled ancestors. Their presence suggests fungi may have prepared Earth for later life in ways we are still discovering, weathering rocks and recycling nutrients in ancient oceans and on bare land, creating the chemical conditions that would eventually allow more complex ecosystems to emerge. 2. Picture a billion-year-old fungus is to confront time on a scale beyond human comprehension, beyond easy understanding. These were organisms thriving in a world utterly alien to ours, an Earth with different atmosphere, different oceans, different continents. Yet their descendants still fruit in our gardens and kitchens, still grow in our forests. Every mushroom we see today connects by unbroken lineage spanning 1 billion years to these ancient pioneers, carrying whispers of a world that barely resembled the one we know, a world we can only imagine through fragments preserved in stone. Fact 95. Mushrooms can form perfect geometric patterns naturally. When mushrooms fruit in favourable conditions, they sometimes arrange themselves in startlingly precise patterns that look designed by a geometer, arcs and spirals, and sometimes complete circles with mathematical regularity. These shapes emerge naturally and inevitably from how mycelium expands outward underground in response to nutrients and space. As the network grows, it exhausts resources at the centre, where it started, and pushes toward edges where fresh nutrients wait, sprouting mushrooms at the advancing front like soldiers marking a battle line. From above, looking down at a meadow or forest floor, the result can look almost designed by intelligence, as though geometry itself had risen from earth to draw diagrams in living matter. Spirals may echo the mathematics of growth similar to nautilus shells and sunflower seed heads. Patterns where efficiency dictates form, where the laws of physics and biology conspire to create beauty. To stumble upon such patterns in a meadow after rain is to feel hidden order has surfaced for a moment, nature sketching diagrams and equations in living fungal flesh. These arrangements remind us that beauty often arises not from intention or design, but from process, from the physics of expansion, from nutrient flow following paths of least resistance, from the silent passage of time allowing patterns to emerge. Mushrooms are mathematicians working without knowing it, etching quiet symmetries beneath forest canopies, proving that pattern and order exist everywhere in nature if we pause to notice and appreciate them. Fact 96. Some spores are designed to hitch rides on insects. Not all spores drift aimlessly on winds hoping for favourable conditions somewhere far away. Some are crafted specifically to cling, covered in microscopic spikes, tiny hooks, or sticky coatings that catch on legs, wings, or fur of passing creatures with remarkable tenacity. Insects become unwitting couriers, delivery services that do not know they are working, scattering spores to territories far beyond wind's reach alone. Certain fungi enhance this partnership further with sophisticated strategies. They attract insects with sweet nutritious exudates or glowing bioluminescent signals, ensuring close contact that maximizes spore transfer. Others grow specifically on flowers or leaves precisely, where pollinators brush past regularly, positioning themselves along insect highways. The strategy is brilliant in its simplicity. Why rely entirely on chance and wind when you can recruit travellers already crossing the landscape with purpose and direction? For insects, the exchange is invisible and unconscious. They feel nothing, notice nothing. For fungi, it is survival extended through partnership, dispersal guaranteed through exploitation of existing movement patterns. The forest fills with these silent bargains where movement becomes currency, and spores ride on wings like passengers boarding flights into unknown territories, trusting in the restless wanderings of tiny creatures navigating the air, following scent trails, seeking nectar, hunting prey, all unwittingly carrying the future of fungi with them wherever they travel. Fact 97. Mushrooms help lock nutrients into soil for future growth. Fungi are recyclers, as we have learned, breaking down dead leaves, fallen wood, and organic matter into simpler chemical forms that plants can absorb and use. But they do more than simply release nutrients back into circulation. They help anchor them in place, preventing precious resources from washing away. Mycelium binds soil particles together through physical entanglement and chemical adhesion, creating stable structures that resist erosion from rain and wind. In forests, this creates a living reservoir beneath the surface, a savings account of fertility, storing phosphorus, nitrogen, and carbon, where roots can access them when needed rather than losing them to streams and rivers. Without fungi performing this service, soils would quickly lose fertility with every storm, leaving plants struggling to find the minerals they need to grow and reproduce. Even in agricultural lands, fungi perform this role if allowed to, keeping nutrients stable and available to crops across growing seasons. Imagine the underground web as a careful guardian, a steward of resources tucking nutrients safely into countless pockets and crevices until they are needed by the community. In this way, fungi act as both recyclers and stewards simultaneously, ensuring the richness of land endures across years and centuries. They are keepers of fertility, invisible custodians maintaining the quiet balance that supports forests and fields and all the life that depends on productive soil to survive and flourish. Fact 98. Fungi create entire underground highways for microbes. Mycelium is not only a network serving its own needs, but also infrastructure for countless other organisms. Studies using advanced microscopy show bacteria use fungal threads like highways and bridges, travelling along them to spread through soil more efficiently than they could alone. The thin filaments provide stable surfaces in the chaotic jumble of soil particles, bridging gaps otherwise impossible to cross for creatures measured in microns. In return for this transportation network, bacteria sometimes share nutrients they have unlocked from rocks or organic matter, or they assist the fungus by producing compounds that promote growth or defend against pathogens. This creates underground systems of roads, junctions and exchanges, invisible to us yet vital to soil health. It is infrastructure as complex as any human city, built not by design but by evolution. Without fungi laying down these thoroughfares, many microbes would be isolated in tiny pockets of soil, unable to disperse or interact. Their potential contributions to the ecosystem locked away by geography at the microscopic scale. With fungal highways, the ground becomes a bustling network full of traffic and trade, information flowing, resources moving, populations mixing. To imagine soil as empty dirt is a fundamental mistake we make by not looking closely enough. It is more like a thriving metropolis, a city underground, thrumming with connections and commerce. Fungi, with their endless branching threads, are the civil engineers and urban planners, laying down infrastructure for countless microscopic lives to travel, meet, exchange, and cooperate in ways that sustain entire ecosystems from the ground up. Fact 99. Some mushrooms smell exactly like fresh bread. Lift the cap of a freshly picked field mushroom, and you may notice a fragrance startlingly familiar and comforting. The smell of warm, yeasty bread straight from an oven, wholesome and inviting. This aroma comes from volatile aromatic compounds, also produced by yeast during fermentation, shared chemistry that links distant members of the fungal kingdom to baking traditions. For people who gather mushrooms as a hobby or profession, scent becomes an important tool for identification, a sensory handshake between species that can confirm or deny identity when visual features are ambiguous. The smell is more than pleasant or convenient. It is evolutionary strategy refined over millions of years. Aromatic compounds can attract insects or animals with far more sensitivity than visual cues, encouraging them to interact with the mushroom, brush against it, and carry away spores to new locations. For humans, the connection feels almost uncanny and touching. To breathe in the fragrance of bread in the middle of a forest, far from any kitchen or village, is to experience comfort in an unexpected place, to feel momentarily that the wild and the domestic have merged. It reminds us that boundaries we imagine between cultivated and natural spaces are often thinner and more permeable than they seem. Chemistry connects disparate worlds in surprising and beautiful ways, creating links we never expected. Fact 100. Others smell like cinnamon or anise. Not all mushrooms carry earthy or musty aromas that remind us of soil and decay. Some release perfumes mimicking spices from distant kitchens and markets, fragrances that seem impossible in a forest setting. Anise-scented toadstools exude sweet licorice-like fragrance that could be mistaken for candy. Certain milk caps smell distinctly of cinnamon when crushed or cut, filling the air with warmth and spice. These aromas come from aromatic organic compounds, identical or remarkably similar to those found in actual spices, convergent evolution producing the same molecules for different reasons in different organisms. For humans, the discovery feels magical and disorienting in the best way, walking through damp woods expecting petrichor and finding instead scent of a spice cabinet, of holiday baking, of faraway markets. But for fungi, these fragrances are functional rather than aesthetic, signals carefully crafted to attract beneficial insects or ward off threats that might damage the fruiting body. Their chemistry is survival, even if it registers to us as delight and wonder. Mycologists often rely heavily on smell during identification, bending low to inhale the secret signatures of species, building mental libraries of scents that guide them through the bewildering diversity of forms. Each aroma is a note in the forest's invisible symphony, a reminder that mushrooms are chemists and perfumers, distilling the air into fragrances we carry with us long after we leave the woods, memories written in scent rather than sight, experiences that bypass language and lodge directly in the oldest parts of our brains where smell and memory intertwine. To encounter a cinnamon-scented mushroom on a cool autumn morning is to be transported momentarily to grandmother's kitchen or a winter market, then return just as quickly to the forest floor, disoriented and delighted by the collision of contexts. These scents prove that the natural world is full of unexpected connections, that chemistry creates bridges between experiences we thought separate, that a forest can smell like home, and home can smell like wilderness depending on which molecules drift into your nose on any given breath.